Welcome to Unit 7, Objective 3. It's where we get away from circles and into parabolas. Now, I know you've studied parabolas before, but there are a lot of things you don't know about parabolas that you're going to learn in the remaining lessons of Unit 7. Now, we can't throw them all at you in one lesson because it would be way too big of an overload. So we're just going to begin with some basic relationships. The parent function, y equals x squared, considering there's, a leading coefficient of 1 right there, means the vertex is at 0, 0. And because that leading coefficient is 1, it's what I call a normal width parabola. Relatively speaking, it's normal. It isn't wide, it isn't skinny. It's just a normal width parabola. And because it's positive, it goes up. Well, what happens when that leading coefficient changes, like this right here? What do those two numbers do to the parabola? Well, they're both still at 0, 0 because they haven't been translated left or right or up or down. The only thing that's changed is that leading coefficient. So I'm going to put my vertex at 0, 0 again. Only thing is, what does this 3 do? Well, it's a positive 3, so I know the parabola goes up, but actually that 3 makes the parabola skinnier. So compared to a 1, the 3 would be skinnier. Now on this one, what does the 1/5 do? Well, again, it's positive 1/5, so the parabola is going to go up. The vertex is still at 0, 0 because there hasn't been any translation. But what does the 1/5 specifically do? It makes the parabola, relatively speaking, wider than the parabola used to be when the leading coefficient was 1. So that's what we call the A value, the leading coefficient of the x squared. So when y equals ax squared, the A will tell us two things, the direction and the width. So if we just had to give a general characteristic of these two parabolas, I would say this is an up wide parabola because of the 1/12. And if I had to sketch it, it would be pretty easy to do. Put your vertex at 0, 0 and just make an up wide parabola like that and like that. There's your up wide parabola. Now, what about y equals negative 4x squared? A general description, because of the negative, it would be down. And because of the 4, it would be, for lack of a better word, skinny. It would be a down skinny parabola. The vertex is still at 0, 0, but I would just make sure I make a down parabola that's on the skinny side. And so that's the first thing we want to make sure you guys understand is that the A value, which is the leading coefficient of the x squared, determines the direction and the width of the parabola. The next thing we're going to do is we're going to do a little bit of algebra practice. Once you see the pattern of this, it's going to come in real handy with some of the things we have to do regarding parabolas. What is 1 divided by 1/3? Well, back in elementary school, you learned that if we were dividing fractions like this, first thing I would say is, let's change this from vertical division to horizontal division. And the problem probably becomes instantly easier. 1 divided by 1/3 is simply the same thing as 1, and division changes to multiplication, and you flip that second fraction, so it's 3 over 1. So the answer actually is 3. So 1 divided by 1/3 equals 3. Now, we certainly don't want you to go through this routine every single time you see this. We want you to see the pattern. What would 1 divided by 3/5 be? 1 divided by 3/5 would be the same thing as 1 times 5/3. Division changes to multiplication, and you flip the second fraction. So 1 times 5/3 is simply, 1 divided by 3/5 is the same as 1 times 5/3, which is 5/3. Now, without having to go through this process again, I would hope you could tell us what 1 divided by -7/2 is. The answer is -2/7. Now that's going to come in real handy because you're going to see something like this quite a lot. Okay, we're back to parabolas again, but you're going to see why we did that little algebra practice. Graph the parabola x squared equals y, and then find certain things that we want to know about that parabola: the focus, the directrix, and the focal chord endpoints. Well, first thing let's do is let's adjust the equation to where the y is by itself. So all we would have to do is divide both sides by 8, and we would end up with the equation y equals 1/8 x squared. Now that would be the same thing as x squared over 8, but we want to actually pull that leading coefficient by itself, because now I know something about this parabola already before we ever even graph it. It's up because the 1/8 is positive, and because it's 1/8, it's relatively wide. So this is going to be an up wide parabola. Now, we also know it hasn't been translated at all, so it's still at 0, 0. The next thing we need is the relationship of C equals 1/4a. And if you're wondering what C is the focal length, the focal chord length. And I'll show you what that's all about in a second. So let's find this C value. C equals 1/4 times the A value. Well, remember that A is the leading coefficient of the x squared, so it's 4 times 1/8. So that gives us now 4 times 1 is 4, so that would be 1/4/8. And because you don't multiply the 4 by the 8, you just multiply the 4 by the 1. Now, if you reduce this, this is 1/1/2. Now, here's why we did that little algebra practice. What is 1 divided by 1/2? C equals 2. Now, that's an important number, because what that does is it tells us we need to take 2 steps from the vertex up to get to the focus, and we need to take 2 steps behind to get to the directrix. So the directrix is down here at y equals -2. So that tells us 2 things already. If I was at 0, 0, and I took 2 steps up, I'm now at 0, 2. Now, if I was at 0, 0, and I took 2 steps back, a lot of students say that that's 0, -2. But remember, the directrix is a line. It isn't a point. So that horizontal line is y equals -2. Now, I also have to go to C. Okay, so if C equals 2, then 2C equals 4. And that comes into play when I do this. From the focal point, I go 1, 2, 3, 4, and I make a point right there. and I go 1, 2, 3, 4, and I make a point right there. And now I know how the parabola opens. I can sketch the parabola like this. And I can also answer these two questions. What are the focal chord endpoints? Well, remember what this was. This was 0, 2. That was the focus. Now, if I went 4 steps to the right, I'm now at 4, 2. And if I went 4 steps to the left, I'm now at negative 4, 2. Okay, let's try this second example. X squared equals negative 6y. Well, remember, the first thing I want to do is get y by itself, so I'm going to divide both sides by negative 6, and I'm going to end up with the equation y equals, now I'm not going to put x squared over negative 6, I'm just going to say negative 1/6 x squared. I want that leading coefficient to tell me something, and it does. What it tells me is I have a down. The parabola I'm going to make is going to face down, and again, because it's 1/6, it's going to be wide. So, these things that I need to find out about the parabola are going to come from that formula for the focal length. C equals 1 over 4a. So I've just got a little bit of work to do. I know my a value is negative 1/6, so C equals 1 over 4 times negative 1/6. Now, this isn't going to turn out as clean as the other one. C equals 1 over, now 4 times negative 1 is negative 4 over 6. And if I reduce that, that's 1 over negative 2/3. And from that algebra practice that we did, we know that if C equals 1 over negative 2/3, then C, I'll start it up here. C equals 1 over negative 2/3, which means C equals the reciprocal of that and negative, so negative 3/2. So that's my value of C. Now you might want to think that more in terms of a decimal. So that means C equals negative 1 1/2. So remember what C tells us. You go 1 1/2 steps to find the focus. But this was a down parabola. So actually you go 1 1/2 steps down. And there's your focus. And you also go 1 1/2 steps up, and there's your directrix. Now, if I was at 0, 0, and I took 1 1/2 steps down, then that means I'm at 0, negative 1 1/2. So that's my focus. If I was at 0 and I took 1 1/2 steps up, that puts me at the y level of y equals positive 1 1/2. So that's my directrix. Now, the focal chord endpoints, they rely on 2c. So if c equals negative 1 1/2, then that means 2c equals negative 3. And I really don't have to worry about the negative part of it because I go in both directions anyway. So what I'm going to do is from the focus, I'm going to go 3 steps to the left, 1, 2, 3, and I'm going to put a point right there. And I'm going to go 1, 2, 3, and I'm going to put a point right there. And now let's just figure out what those 2 points are. Remember, the focus was 0, negative 1 and 1/2. 0, negative 1 and 1/2. Well, if I take 3 steps to the right, I'm now at 3, negative 1 and 1/2. And if I take 3 steps to the left, I'm now at negative 3, negative 1 and 1/2. And the last thing I need to do is draw the parabola or sketch it. And there it is. This last example is going to help you guys tremendously with problems 7, 8, and 9. It's a different concept now because we're trying to write the equation of the parabola. In all the previous examples, we knew the equation of the parabola, and we were just sketching it to see some of its characteristics. Well, now we know some of its characteristics. We know the focus, or the focal point, and we know the directrix. So write the equation of a parabola that has a focus at 4, negative 3, and has a directrix of y equals negative 11. Well, here we get into one of the many relationships of a parabola. For any point on a parabola, any point at all, let's say this one right here, it is equidistant, so the 2 distances are equal. The distance from that point to the directrix and the distance, the distance from that point to the focus is the same distance as that to the directrix. Those 2 distances are equal. And that's what we're going to use to help us figure out the equation of this parabola. Now, we have no idea about this point right here. So we're just going to call it x, comma, y. Now, we do know something about this point right below it. The fact that it's right below it means it has the same x coordinate. So we're going to say x again, but we also know its y coordinate. It is at negative 11 as far as the y is concerned. So, since the whole relationship is based on having the same distance, the distance formula is going to play a big role in what we're about ready to do. Let's find the distance from this point to the focus. So the distance formula says we subtract the x's, so this would be x minus 4, and we would square it. That's part of the distance formula. And then the other part of the distance formula says you do the exact same things to the y's. That would be y minus negative 3. And we square it. Now, the characteristic about these 2 distances is that they're equal. So I'm going to set this distance equal to this distance. So I'm going to do the distance formula all over again, only from this point to that point. So again, I subtract the x's. So in this case, it's x minus x squared, and it's y minus negative 11 squared. So everything starts from there. This distance equals that distance. Now, we're going to just start doing some simplification. We're not going to do anything over here. X minus 4 squared plus, now the only thing I'm going to do right here is y minus negative 3 would be y plus 3 squared equals, now I can simplify this side a little bit because I know x minus x is 0. And when you square 0, you still get 0. So the only thing I have over here on this side would be y minus negative 11 squared, which is y plus 11 squared. Now the next thing I'm going to do to get rid of these square roots, I'm going to square both sides. And that just means I end up with x minus 4 squared plus y plus 3 squared equals y plus 11 squared. Now from here on out, it's just some binomial multiplication, some foiling. So x minus 4, when you square it, is x squared minus 8x plus 16. When you expand this out, now the same thing when you expand out y plus 3 quantity squared, you get y squared plus 6y plus 9. Now over here on this side, when you expand y plus 11 quantity squared, you get y squared plus 22y plus 121. So really all I did was a bunch of foiling at this point. Now I'm going to start looking at what can I simplify. Well, there's no other x squared on the left-hand side. There's no other x. So I've got x squared minus 8x. I can put these two constants together. 16 plus 9 is 25. Now, I've got plus y squared plus 6y, because remember I already put the 9 and the 16 together to make 25, equals y squared plus 22y plus 121. So that was my next step. Now my next step is going to be, see that y squared on this side and that y squared on that side? If I tried to move one over to the other, they would both cancel. So they cancel each other. Now, I'm going to take the 6y over there, and I'm going to take the constant over there as well. And that's going to leave me at x squared minus 8x. Now this is gone, and that's gone, so I just have my equal sign. Now 22y minus 6y is 16y, and 121 minus 25 is 96. Okay, now remember back in Objective 1 where we learned how to complete the square? I need to complete this square. I need to make it a perfect square trinomial. So it's going to be x squared minus 8x plus whatever that third term is to make it a perfect square, 16y plus 96 plus whatever I do over here, I need to do over here. So let's figure out what I need to do. Take negative 8, divide it by 2, and you get negative 4. Square that answer, and you get 16. What I do to one side, I have to do to the other. So I added 16 over here, so I need to add 16 over here. Now we're almost done. My perfect square that I just created was x minus 4 quantity squared, because remember, when you complete the square, it's always this 1/2 number, equals 16y plus, now 96 plus 16 is 112, and this is going to be my last step. I'm going to leave the left-hand side alone, x minus 4 squared equals, I'm going to factor out a 16 from both of these, and I'm going to get y plus, and when you take 112 and divide it by 16, you get 7. And that's the equation of the parabola.